In this video, I'm just going to run through really quick explaining what the unit circle is, and then I want you to go back in your notes and see the key and try to fill this all in yourself. So the unit circle is a great reference for seeing reference angles for finding cosine and sine. So remember that the cosine is always our x value and the sine is always our y value. So a unit circle is just a circle with radius 1. If I find a point on the circle, xy, that point tells me, if say I rotated 30 degrees, that point tells me here's the cosine and here's the sine. So having this unit circle memorized is actually really, really nice, and it's a great reference for you to see everything that's going on. The way we form the rest of the unit circle, so we just decided, 30 and 45 and 60 were some pretty important angles, so that's how we just kind of picked those points on the unit circle. Now, we also can form other points based on reference angles. So if this is 30, remember the three angles that correspond to 30 degrees are 150 degrees, 210 degrees, and 330. Notice for these 4 points, they all have really, really similar values of cosine and sine. The only difference is whether they're positive or negative. So remember, all students take calculus tells us where they're all positive, where just sine is positive, where tangent is positive, and where cosine is positive. So that's why this set is really, really nice for us to figure out cosine and sine if we know the reference angle. We do the same thing for 45 degrees. It corresponds with the angles 135, 225, and 315. So for all those three, 45 is the reference angle. And notice how similar the x and y values are. Lastly, we have 60 degrees. So that goes with 120, 240, and 300. And again, these values are similar. The only way they differ is by positive or negative. Then we also, in a previous video, learned about quadrantals. So we learned about 0 degrees and 90 degrees and 180 degrees and 270 degrees. And here's those values. So this unit circle is an awesome summary for you to use anytime you need to figure out the cosine or sine of an angle or try to figure out what's the reference angle. So I suggest if you don't have it printed in color that you try to highlight it like this so you can really see what's going on. You might notice as well that there's these little pi over 6, pi over 4, pi over 3. We're going to learn about that really, really soon, what those are there for. So you can copy them down for now if you want, but I don't expect you to know what those mean for a little bit. On the back of the unit circle, you see these graphs of trig functions. So you can actually graph these and find the value at certain points. So I graph this every time from 0 to 2 pi. And you might say, why did I pick 2 pi? That's because 2 pi, this is actually from 0 to 360, which is 180, 90, and 270. So for now, I just want you to see what these different functions actually look like if you were to graph them one by one. So sine, you realize, starts at 0, goes up to 1, goes back down to 0, goes down to -1, and goes back up to 0. Cosine's kind of flip-flop to that, and tangent, again, is pretty funky. For right now, I just want you to be able to recognize these graphs, and also notice how in a dotted line on these other trig functions, that's sine. Cosecant's 1 over sine, which is why it's flipped. Look at this dotted line. That's cosine. Secant is just cosine flipped. And lastly, cotangent's a little weird, but notice it's almost kind of like a mirror flipped image of what's going on here with a little bit of a shift. So for now, all I expect you to do is be able to recognize the graphs of these functions.